Okay, good afternoon. So in this session after the lunch, we will continue with our PLC programming. So before the lunch break, we did timer and counter and other basic and or not XOR, yeah, NAND or logics. So if there are any questions from the centers, you may please ask. Okay, so let us resume our today's session on PLC programming. So now after lunch we will discuss latching, internal coils and analog input. We will also see physically two sensors, one a digital type, second an analog type. Now first of all, latching we will discuss. So to understand latching, let us go to our simulator. Now again, this is the simplest program. With I8, we start Q6 or stop Q6. You close I8, the Q6 runs. You open I8, Q6 stops. Now, what if we want the Q6 to work when we receive a momentarily input or an impulse from I8? And after that, even if the input is gone, the Q6 may keep on running. An example is kind of burglar alarms. Right? So if somebody passes in front of some sensor, the alarm should start ringing, and even if the person has passed and he is no longer in the vicinity of the sensor, the alarm should keep on ringing. That is, we say that we are latching the output. The output will activate when the input was given to it, but even when the input has been taken away, the output will still work. So a basic latching circuit that you will find in the books, first I will draw that. We will just modify this one. For example, here we insert Q6 as an input. Right. Now if we run the simulation, so you will see when we close I8, Q6 runs, because we have put Q6 in the logic circuit on the input side also. Even if we switch off I8, this circuit remains closed and Q6 keeps on working. And this we will see in the video also. Right. Let us first of all see the video. So a motor runs when an impulse is provided, and it's the same program that I made there. So let us see the video. So the motor was started by pressing I8, but now I8 has been released, still the motor is running. So this is called latching. Now in the video you saw that when you close I8, the motor starts running and thereafter it keeps on running irrespective of whether I8 was released or not. So when we carry out latching, we need to provide some method of interrupting the output. And that method is shown here. So now we are making use of two inputs, I8 and I4. I4 has been put as a complement. So that means when we close I8, because this is already closed, by default closed, the circuit will be complete. Even if we remove I8, the circuit remains complete from this side. Now after that, we need to give a momentarily input to I4 and the output will stop.
I8. Release I8. I4.
Right. So momentarily input was given at I4.
Release. I4.
Right. So we give an impulse at I8 and the output starts. We give an impulse at I4 and the output stops. Next is internal coil. Right. Internal coil or internal relay. So what is this? So it says a motor. Now the problem is a motor runs when multiple contacts are closed. That is more than one, maybe 2, 3, 4, 5, 6, 10. For example, in automation, in totally automated factory, an AGV may come to a docking station of a CNC machine. So when the AGV docks, there is a sensor which tells that AGV has docked, and then AGV may be carrying a raw workpiece. So another sensor will determine whether the AGV is carrying a workpiece. Machining may be already going on the CNC machine. So we need sensor inputs to come to know that machining is complete. And then if the machining is complete, a robotic arm or a manipulator has to unload the workpiece from the CNC machine, put it on the AGV, pick the component from AGV, put it on the machine. So in all this, the manipulator must come to know that there is space on the AGV where it can place the workpiece. Right. There are so many inputs which needed to be sent to the controller so that the proper sequencing of operations can be carried out. Now when there are multiple inputs, sometimes we need internal coils, or sometimes to temporarily store a value also we use internal coils. So let us demonstrate what is internal coil. Let us say there's the output is Q6, and this output will work if four inputs are given to it. Maybe I8, I9, I10, I11, like that. Now, one thing is we know that if I need to put four inputs, I may put I8 here. Here we cannot put an input. I9. Here we cannot put any input. I10, and that's it. Right. So in case our logic requires that the output will work when four inputs are there, then we will not be able to do so. In that case, what we do is we make use of internal relays or internal coils. So as the name suggests, because relay or coil we use for an output device, but here we are using the word internal. That is something which is internal to the PLC, It is not a physical device which is attached to the PLC. So in this particular software, internal relay can be used or simulated by from the tab M. Now if you see this M and Q, they look similar. The only difference is in Q we have numbers 1 to 8 and in M we have numbers 1 to 16. So that means that we have more virtual devices available than the real one. So let us replace this Q6 with an M. Now I can put any number M1, M2, M3 because remember it is a virtual device inside the PLC, it is not a real one. Now in the next line we will put the same M1 in series with the fourth physical input, that is I11. And then we put the physical device on the output side. So what we have is we have something in series. When I8, I9 and I10, all the three are on, the internal relay will be switched off. So when that happens, this will be closed. So when I11 is also closed, then this circuit will be complete. So let us run the simulation. So if we close I8, I9, I10, then our M1 is closed. So the power flows up to this point. Now we close I11 and the output is switched on. Now if I8 or I9 or I10, any of the three is switched off, then naturally M1 will be off. So M1 is off, so that means here M1 is open, so this circuit will also be open. So internal relays can be used for temporarily storing some value in PLC programming. Let us see the video demo of it. Right. So we have same program.
8, 9, 10, 11, 3, 8, press 8,
So that is about internal relays. Okay, this timer and counter we have done. Now a sequencing operation, it is basically logic only. There is a, so what are the sequencing? That double acting cylinder and single acting cylinder extend and retract in a predefined sequence. So in this program, although we will not discuss in detail, but what you can see is we have a sensor I1, that is a proximity switch. We are making use of a timer. We are making use of an internal relay. This is the actual coil. Another timer T2. Then Q3 is the coil of the single acting cylinder. Another timer T3. Then M1, this coil is same, but S and R is set and reset. This is basically a shortcut to latching. And here we are using M1 to this. So you can just see the video.
start.
So one cylinder extends after a certain time delay. the second extends, then after some more time delay, they will retract. So they are retracting simultaneously. So it's a very common operation. Normally in say when you holding an object, one cylinder will move to hold an object or position it, second will then come to actually grasp it, and then some operation will be carried out. So we have not used any other special feature in this program, but the timers, the internal relays that we had discussed, they have been used in this program. Now, in learning the features of PLC programming, the last part is our analog inputs. And to understand this application of analog inputs, we have framed a problem that a temperature sensor in a room switches the fan on when the temperature crosses 18 degrees centigrade, and then switches the AC also on when the temperature crosses 30 degrees centigrade. If the temperature falls below 30 degrees centigrade, the AC is switched off, and if the temperature further falls below 18 degrees centigrade, the fan is also switched off. So that means we are saying that there is a temperature sensor in a room which is continuously monitoring the room temperature. So it's an analog sensor. Or if we consider any other sensor like a load sensor, that is an analog sensor. A pressure sensor is an analog sensor, whereas proximity sensors, they are typically the digital sensors. So how do we use analog inputs with PLCs? That we will discuss. But before that, let us see two type of sensors, digital and analog. So what you see on the screen is a proximity switch. It's a capacitive type proximity switch. So which has a detection end. If something comes within a certain range here, it will give a signal. Now basically the working of a capacitive proximity sensor is based on disturbing the electrostatic field of the capacitor which is inside. So every sensor will have fundamentally three wires. We will supply some input to two wires, and the output will be available at the third one. For example, what you see here is that this sensor has three wires, blue, brown, and black. On the sensor, it is mentioned that which wire is for input, which wire is ground, and at which wire you will get the output. Accordingly here, to the brown one, the red wire of the snap is attached, and to the blue one, the black wire is attached. So this is the ground basically. So we have a 9-volt standard battery which is attached to these two. Now, if the output can be measured across this black and this blue, right? So when you attach this sensor to a controller, you will essentially attach this connector, this end to the ground of the controller, and this to the appropriate port of the controller, maybe 1, 2, 3, 4. and the energy it may get from an outside source, or there may be some DC volts available from the controller only. So that DC volt you can apply across this and this. So when an object will come near this, a voltage will develop across this junction, across this terminal and this terminal, and that voltage is now detected by the controller. So the controller knows that the sensor is giving it a signal. Then based upon the logic, the controller will do something. So that's what it is shown here. Maybe here you may be able to notice that all sensors usually have some kind of a visual indicator attached to them. So this one also has an LED which is here. So in the next screenshot, when you see the finger in front of the sensor, you may be able to see an LED glowing at here. I don't know whether it's visible on the screen in the centers, but it's actually glowing. So anyway, we'll also demonstrate it here right now. So Deepika, we need sense camera. Deepika, camera. थोड़ा सा वो कर देना, zoom कर. Zoom हो जाएगा इसको. Okay. So this is the same sensor that you are seeing on the screenshot, right? You may be able to see it is written here capacitive sensor, and on this label only all the information is provided about the kind of the sensor and where to connect the inputs, from where to take the outputs. That is too small, may not be visible on the camera. So this sensor has 3 wires: brown, black and blue. So brown is for giving the positive, blue is for giving the ground, and we can get the output on the black and this. So as I said, to any controller at the appropriate input port, we will attach the black wire and the blue will go into the ground. Now for demonstration here in the classroom, we will use a multimeter. Let me just set it, then I will turn the face of the multimeter towards the camera. That is fine. Okay. So we'll make use of a multimeter to detect the output on the output terminal of the sensor when an object will come near it, right? So for that, because we'll be using a simple 9-volt battery, right? 9-volt cell. So the output will also be at the most 9 volt. So what I'm going to do is I'm going to set the knob of this at 20 volt DC so that we can set a range. We can see the output to 220 volt. So because primarily the uh, participants in the course are from mechanical, so just to freshen up. So if I attach the terminals to the positive and negative of the cells, let me switch it off, keep battery keeper off. Black in there. Black. I think yeah. So this multimeter sometimes it creates okay. Now it's fine. Okay. I think it is. So it should show a 9 volt rating. Now it is fine. Okay. So when we attach this can also come. Yeah, that's right. So when we are trying to see just simply the output of the this frame is fine. This frame is fine. Right. So we see 9.71 volt from this cell. Thank you. Now next what we'll do is we'll simply supply this energy to the sensor. Right. So now we have attached a 9 volt battery to the sensor. So before we see the output on the multimeter, let me show you the back. It has an LED at the back. So if my hand comes close to it, the LED will glow. Right. My thumb is not touching it. It is around 2 mm away from it. So this sensor says that it has a range of 8 millimeter, but it requires 10 to 30 volt DC. It is written on this. We are supplying it a lesser voltage, so we may not be able to work up to 8 mm, but it's working up to say around 2 mm or so. Now this was only a visual indicator. Now how will the controller know that something is there? The controller will know when it detects a voltage across this and this. So this wire will be attached to the input port of the controller and this to the ground. Now I will request a participant here. Right here. Which one? Yeah, pick up. Language hang कर ला. Hang कर लो ताकि protection की हो. Okay. Now what you see is right now we have attached the output of the sensor to the multimeter. So what you see on the multimeter is a 0 volt. But if I bring my hand near the sensor, you will see a reading on the multimeter, right? Let me see again. So on the back of the sensor, you will be able to see the light glowing, the LED glowing, and also you will be able to see the output on the multimeter. Right. So that is how, and when the object is gone, the multimeter reading is 0. There is no output available on the output terminal of the sensor. Right. So that is how we attach the digital sensors into the controllers. Whether it is a PLC or it's a microcontroller, whatever, the principle remains same. So another thing. So as you saw, this was a digital kind of a binary rather, because it gives an output only when the object is present. Otherwise, it doesn't give an output. Now let us see a very simple analog controller, analog sensor. So rather than going on the board, I'll go to the laptop. उसके बाद दोबारा से यहाँ पर आएंगे. So that is a potentiometer, right? It's a very simple device, yet it is omnipresent. The fan regulators, they are potentiometers essentially. So in potentiometer, what we have is we have a resistance to which we supply a fixed voltage. If the resistance is say capital R and the voltage is say capital V, then the current in the circuit will be how much? V by R, right? So now the current is flowing through the resistance. Now if we measure a voltage across the whole of this resistance, then the voltage will be same as applied to it. But if we measure the voltage across a part of the resistance, the voltage will be I into R, that is I, which is the current flowing through it, multiplied by the part of the resistance across which we have kept the probe. So that means if this pointer is somewhat over here, the output voltage here will be 0. So as you move the pointer up, the output voltage will go on increasing, and if this pointer is kept here, somewhere here, then since it is measuring voltage drop across the whole resistance, so the output voltage will be equal to this. Now what does this mean? That we are transducing a displacement signal into a voltage signal, because as the pointer is moving, that's a displacement signal. So we transduce a displacement signal into a voltage signal by means of a potentiometer. Potentiometers, as I said, are very common. Fan regulators, volume knobs of radios, right? So uh, normally we come across. Normally we come across this rotary type of potentiometers like the radio knobs, like these kind of this or maybe this, they are all same. But sliders are also there. Sliders are called faders, right? So this is a slider, right? So again, this image is from Wikipedia, but the same fader we will demonstrate here in the classroom. So the kind of fader that you saw on the computer screen, same fader is here, right? So this slider can move from one side to the other side, right? So like the digital sensor, this also has three terminals, right? Across, sorry, three terminals, red, we have a red wire attached to one, a yellow wire attached to the other, and there is a third white wire. So we will supply the input across red and yellow and measure the output across white and yellow. So same battery we will attach to it. Same so red and white. horizontal कर लो, ठीक है. Now what you see on the multimeter is 9.22 reading. So that is because this slider is on one end. If we move the slider to the other end, my hand is coming but doesn't matter. नहीं वो छोटा कर दो, फ्रेम बड़ा कर दो, कोई नहीं, आप मेजर से करता हूँ, ठीक है. So what I will do is I will just move the slider, and you see as the slider moves, the voltage reading is varied. So that means we are transducing the displacement signal into voltage signal, and as you can see in this case it is an analog sensor because it is continuously giving a number of outputs, right? It will go up to almost 0. On one end is 0. So as we go on moving the slider, the output displacement will go on increasing. Right. So this is the other extreme. Right. So that is an. So we have just discussed digital and analog sensors. Now on the now we'll go on. Now if we again go back to our overall board of the PLC. So here all the sensors 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the 11 sensors are digital sensors. The difference is that 1, 2, 3, 4, these 4 are capacitive type proximity sensors, the kind of one you saw just now in the demonstration. These 4 are inductive type. So that means they will detect only metallic objects, whereas these will detect anything which can kind of, you can say, provide changes to the electrostatic field. It was hurting my hand also. And the last 4, they are limit switches, so they are contact type. The first 7 are proximity, the last 4 are contact type. Now in our PLC, in this, out of the 12 inputs, 2 inputs are provided where analog sensors can be attached. They are input number 7 and 8. Now let us go to simulator to understand 7 and 8. Now I have used I8 in a number of simulations. I'm going to use again it. Now when we simulate and the I and Q window appear, in I window we have I1, I2, I3 up to I16. But we also have 2 sliders named I7 and I8. Right. Now during simulation, if I click this I8 here, you will notice that this slider will jump from here to here. Right. The slider is jumping from bottom to top. That is, so I7, I8 have been provided here because in this particular PLC, 2 inputs I7 and I8 are also designed to take analog values. So what we'll do now is, you will see, we will simulate the program and you will see a video also in which you will see the same potentiometer that we are using to run 2 motors for different values. Now let us first of all see how do we How do we use an analog input? Now when we use I from the contact coil window, it's by default, or these are all meant to be treated as a digital inputs. Now to incorporate analog, this simulator provides another tab, that is A for analog. So I pick A from here. Now we can take any number. When we take a number, it gives us a lot of options. I will focus only on one option, this one which says I8 is greater than equal to value. And what value? That I specify here. And as you can see, the value can go from 0.0 to 9.9. That means that the input ports of our PLC can take a voltage from 0 volt to 9.9 volt. We shouldn't give more than that. So I specify here that I'm going to 5 volts, 5.0. Accept. Now let us simulate this. Now instead of using I8, I will use this slider. So as I increase the value, you will notice that the actual value here increases. Right. Now once this value reaches 5 volt, the output will be switched on. Right. More than 5, it will remain switched on. But if we reduce this, then it will, less than 5, it will go off. Now again coming to our example, which says that when the temperature in the room crosses 18 degrees centigrade, then a fan is switched on, and when it crosses 30 degrees centigrade, then the AC should also be switched on. So let us try to simulate it. Let us say fan is Q4 and AC is Q6. I have used A1 here, so I will use A2 here. But actually A2 will also refer to I8 only. Right? A1 was also referring to I8, but there when if I8 is greater than 5, let me make it 3. Sorry. A1, we make it 3 instead of 4. Accept. And here we will take A2. A2 will also refer to I8 only, physical input I8 only. Here we say 6.0. Accept. So what we are telling our controller is that if the voltage signal at I8 crosses 3 volts, then you switch on Q4. And if it crosses 6 volt, then switch on Q6 also. Now let us simulate it. So although here we are A1, A2, but remember both A1 and A2 are referring to I8 only. So we need to move this slider only. So as the increase the voltage, once the voltage reaches 3 volt, one output is switched on, that is Q4. When it reaches 6, the second is also switched on. Then both will now remain switched on as per our logic, right? So when we decrease it, it goes below 6, Q6 is off, goes below 3, Q4 is also off. So for the same thing, now let's see the video. Right. So it's the same program. And in the video you will see we use the same fader.
hold,
So this is the same fader.
start,
So as we slide it, it reaches a certain value, one motor starts. When we slide it further,
proceed,
then the second also starts.
over, start back, start back,
Right. So depending upon the amount of voltage that we provide to the controller port, it will switch on or switch off different inputs. Now any uh, questions from the centers? Gyan Jyoti,
No questions, sir, from our side, Gyanjyoti.
okay, thank you. Punjab University Regional Center Sharpur. If there is any query, we cannot hear you. Maybe your mic is mute. Their mic is on. हाँ जी? Okay. So maybe your external mic is off or something. Okay. Gate, Odisha. Is there any query? Yes, sir.
No, sir.
Okay, right. Thank you. SCS VMV University.
Hello, sir.
Yes. Yes, please.
So if the room temperature is increases, we can detect the through the temperature sensor, right?
Right.
Suppose if it is very cool due to AC,
Mhm.
how which one it's going to be detected? The same sensor or a different sensor?
No,
What is the range of temperature it can measure, sir?
yeah. You see, whenever we select a sensor for a particular application, the first criterion is that what should be the range and span of the sensor. Right. That is
Oh.
the fundamental static characteristic that we will take
Okay, sir.
for selecting a sensor. So naturally, if in a room the sensor is going to vary, temperature is going to vary, say from 0 degrees centigrade to 40 degrees centigrade, we'll ensure that we select a sensor which is able to measure that.
Okay, sir.
Yeah. The rest all depends upon the logic.
Okay, sir. Suppose if there is no person is present in this hall,
Yeah.
how this can be detected, and you can switch off the AC or whatever the things.
Well, there are actually a variety of sensors.
Yeah.
Usually for detecting the humans, there are sensors which are based upon pyroelectric principles.
Oh, okay, okay.
So they are able to detect the thermal heat of the humans.
Okay, sir.
Yeah. So
Thank you, sir.
okay. Okay. So uh, because this course is of 5 days, and in 5 days we can only introduce you to the different concepts. So in one day we have given you a very, very, very wide spectrum of information, but this is because controllers are very important part of automation along with sensor and actuators, of course. So a few more sensors we will discuss as the course progresses. Now I just want to show you a small video. So what you see on this screen is a small setup where there is a conveyor, and to run the conveyor there is a very small motor, a small DC motor, and then there is a sensor here. This sensor is basically a color sensor detecting the color, and this is a microcontroller, and this of course is the power supply, right? So just first you see the video. I think it has a video also. Okay, that's here actually. So what you saw was that of course there was an attachment above. So black color blocks were going this way and white color blocks were going the other way. Now, so here a small microcontroller is used. So tomorrow in the morning session we will have a session on microcontrollers, where the expert will also, he will bring a microcontroller, show to you how to program, and maybe show some simple examples also in the classroom. Now today, uh, before we end this class, let us go through how PLCs can be used, and it will cover a wide variety of things. So it is basically a thesis of one of my students. So what he has done is fundamentally he has made a XY table, right, using stepper motors, sensors, and operated it through the PLC. So this is a CAD model of the that XY table. This Y color is the base, red color is the, you can see Y, yeah, that is Y, and this green color is for X. On top of green, there is a jaw, a movable jaw operated by a pneumatic cylinder for holding an object, and the object will be detected by this sensor. So this green slide base, which will move in the X direction, it is moved by this stepper motor, and this red colored slide base, which will move in the Y direction, it is moved by this stepper motor. So there are sensors for detecting the zero position of X slide, and another sensor for detecting the zero position of Y slide. So the components are, there is a fixture, then there is a PLC, then there are sensors. Two types of sensors have been used, capacitive and inductive. Pneumatic actuator has been used, 5x2 DC valves, stepper motors, and driver circuits, electronic circuits. So it's just a simple stepwise steps of this, that first the gripping mechanism is designed, then sensors and actuators are selected, then kinematic design of the positioning mechanism, fabrication of XY table, torque computations for positioning mechanism, selection of sensors and actuators, interfacing of sensors and actuators with PLC, design of logic, then ladder diagram development and testing and validation. So because the workpiece was to be gripped in which the the drilling was to be done. So first of all, the axial thrust was computed, which is required during drilling. So based upon that, a pneumatic actuator was selected. So these are design parameters. If you drill a hole in the component was taken off a wood. So these are the equations for calculating the clamping force, and from clamping force, frictional force. So based upon that, a pneumatic actuator was selected. So these are the specifications of the pneumatic actuator. Then the positioning mechanism. So this is the upper slide. So this is the pneumatic actuator, and this is the jaw which will move in these grooves. And this is the capacitive type proximity sensor which will detect the object. This is again the side view of the same slide. So this lead screw mechanism is attached to the stepper motor at this end, and these wheels, they will move in the grooves on the lower slide. This is the lower slide. So the upper slide wheels will move in these two grooves, and this is the stepper motor to which the upper slide was coupled, and this is the inductive proximity sensor to detect the zero position of the upper slide. So side view of lower slide. So lower slide also has wheels that will move in the grooves on the base plate. So this is lower slide mounted on the base plate. So here you can see that this lower slide will be operated by this stepper motor, and the upper slide which will come here will be operated by the second stepper motor. This is the base plate. Now this is the complete assembly. So then basically how motors were selected. So the torque calculations for selection of stepper motors. So that was the data. This is the torque calculations, and using this, these two motors were selected, having a torque of 5 and 7.2 kg centimeter with these current rating, and step angle was 1.8 degree. Now these are travels of upper and lower slide. So it is basically 1.8 degree step is there, but in the logic, the driver of the stepper motor was designed that when a pulse was given to it, it moved it through 40 pulses. Yeah, 40 pulses. So 40 steps. So 40 steps means each step of 1.8 degree. So 72 degree in one go. And the pitch of the lead screw was 1.3 mm. So if since 72 degree rotation with this pitch, the slide would move through 0.26 mm, which is quite small. So any resolution is possible with this. Similarly for the lower side travel. Then these two sensors were attached to the PLC. DC valve was attached to PLC and stepper motors to PLC. So it is the same PLC that was used by the student. So this is where the sensors were attached. This is about where the valves were attached to output Q1, Q2. Now here the this voltage converter 1 and 2 are for the driver circuits of the DC motors. These are the sensors. So this shows a close-up view of input ports of the PLC. Since it is the same PLC, you can see I1 to I12, and there are two ground ports provided and one for taking a voltage of 24 volt DC. This is a directional control valve. This is how the directional control valve was linked to the output sides of the PLC. These are the stepper motors. So from PLC, the output was given to the driver circuit. On the driver circuit, there was a microcontroller which would give them the pulse to the stepper motor for driving. So this is the basically a voltage converter, because the output of this particular PLC is 24 volt. So a circuit was required to step down 24 volt to 5 volt, because the microcontroller will take a 5 volt. So here from PLC, the output of the PLC is given to the voltage converter, and the output of the voltage converter was then given to the microcontroller circuit. From there to this is a motor driver circuit. This is the microcontroller and this is the motor driver circuit, which will actually drive the stepper motor. So from here you see, from the voltage converter, this is the output from PLC. The voltage are stepped down to 5 volt. Then through this ribbon cable, the output is given to the microcontroller, and from the microcontroller, the output is given to the driver circuit of the motor. And these wires from the driver circuit are going to the stepper motors. So this is the flow chart. Various components used, and this is a ladder diagram. So I think there are two videos also. One video is for homing. Homing is that where X and Y will move to their 0, 0 position. Now in this mode, the stepper motors were run continuously. And when these sensors will detect this, or the stepper motor will stop, because these will detect the 0 position. This one of the upper slide and this one of the lower slide. Okay. So as these two gave a signal to the controller, the motors were stopped. This is about the starting. So when the object is placed, or there is a time delay, and after time delay, the jaw will hold the workpiece, and then the appropriate motion to the motors to position the workpiece. So now the stepper motors are moving in each step through 72 degree, and thereby moving the slides through 0.26 or whatever linear displacement is there. So basically, based on this, what was done, that this whole thing was operated with a marker mounted in the bridge to test the whether the positioning was okay or not. So, for example, this was that it was required to mark 2 points. This is the reference point, and these are the XY coordinates of these 2 points. So then the test run was made from 0, 0. The marker moved, the XY table moved like this, so that the marker traced the path up to the first point and then to the second point. Similarly, for these 2 points, the marker traced to the first point and then to the second point. For these 1 and 2, this, and this. So in this, we have basically introduced that for actuators, you need driver circuits, microcontrollers, because in a CNC machine also you will have a number of microcontrollers, maybe a few PLCs also, depending upon the complexity of the machine. So sensors, actuators, controllers, signal conditioning, that's a very important part of automation. So today we discussed PLCs. Tomorrow in the morning we will have microcontroller session. And tomorrow afternoon we'll have some, I think, case studies on automation. And then Thursday will be on robotics, Thursday, and Friday on control systems. So we'll break for the day. If there are any questions, you can please ask. The difference between a PLC and a microcontroller is that a microcontroller is very small, IC, right? So you use microcontroller is what you call as embedded controller. You can put it in a device. Like in automobiles, you have microcontrollers in the engine control unit, ECU. In toys, you have microcontrollers. In washing machines, you have microcontrollers. So you use microcontrollers when that product is to do the same thing throughout its life cycle. Same thing again and again. But because you program it, because tomorrow you will see that when they program it, there will be a small kind of a PCB circuit on which that microcontroller will be there. Attach it, they will tie through a USB port to the PC, make the program, transfer the program to the microcontroller. Now you can take the microcontroller out and put it where it is actually used. Okay. Whereas in case of a PLC, we use it on the industrial shop floor where programs may have to be changed. It's quite easy to reprogram the PLC as compared to a microcontroller. Number two, microcontroller will have limited number of inputs, outputs, 10, 15 inputs, 5, 10 outputs. A PLC can have hundreds of inputs and hundreds of outputs. You can just, depending upon the resource capability, you can keep on attaching input-output modules to a PLC. And PLCs can be very large also. But both are controllers. Both have a CPU, both have RAM, both have ROM, both have input-output interfaces. But only the microcontroller is something which is very inferior as compared to a laptop or a PC. Its clock speed is less, its memory is less. PCs are very, very superior controllers. They have very high clock speeds. Why? Because whatever program you run on them, it runs basically on it's software based. Whereas in microcontroller and PLCs, many actions are hardware based. Yeah, there are some applications where you can use it.